Hi everyone, my name is Nathan Cooper and I'm one of the authors as well as the presenter for today's paper, Translating Video Recordings of Mobile App Usages to Replayable Scenarios. Now, video recordings of mobile app usages has a wide variety of use cases. The one that I'm going to be focusing on today, however, is video-based bug reporting. Here are 3 examples where each video denotes the steps in order to reproduce a particular bug in an application. This can be extremely useful for testers or end users where they're generating these videos and pushing them to GitHub or GitLab or any other issue tracker where mobile developers can review them. However, this can quickly get out of hand if the amount of videos starts getting too hard to process due to the manual nature of reviewing the videos in order to reproduce them or understand the bugs inside of them. This is where V2S comes in. V2S stands for Video to Scenario, and it's an automated approach for replaying mobile app usages by taking a video and producing a script that can be reran on a physical or emulated device to reproduce the actions present in the video. It has 3 main phases. The first phase is all about determining where in the video the user is interacting with the device. To do this, we first break down the video into its constituent frames using FFmpeg. Then we analyze each frame in the video to determine where the user interacted with in the screen. To do this, V2S requires the developer option that visualizes the touch that the user does with this white circle. This developer option is available on any modern Android device and does not require any sort of rooting of the device. With this option enabled, V2S then uses a faster RCNN object detection network to process the video and predict where in any of the frames there is an object, this touch indicator, present. To train the network, we use the redraw dataset, which is a large collection of different applications and their screenshots. We take each screenshot and we randomly overlay this touch indicator on top of the screen. This allows us to generate a wide variety of training examples to make our approach robust to different applications. Next, we have to determine what state the touch indicator is on. The touch indicator has 2 main states. One where the finger is touching and the opacity of the touch indicator is at its fullest, and one where the finger is being lifted and the opacity is slowly fading. This is required in order for us to disambiguate some of the more complex cases where the user is typing really fast or is doing actions in quick successions that may get blurred together during the video. In order to determine these states, we use another network based on the AlexNet architecture. To train this second network, we also use the redraw dataset in a similar manner where we just take random crops from the dataset and overlay the touch indicator with varying opacity levels. Next, for phase 2, we take the recognized touch indicators in each of the frames and we try and group them through the video into the actions that they belong to. To do this, we model it as a graphing algorithm, specifically a modified version of the connected components algorithm where each node is considered a touch indicator. Here are some of the rules that we use for connecting the touch indicators together. First, we only connect to an immediately successive frame. So a touch indicator at time t can only connect to a touch indicator at time t plus 1. Additionally, we never connect from an ending node where the finger is lifting to an active node where the finger is touching. Also, if multiple choices, such as in the example at t plus 2, we pick the node with the closest distance to the node that we're currently on to connect to. Also, for action classification, the touch indicator through the life of the action doesn't move more than 20 pixels. We consider it a tap or a long tap, and we consider everything like a swipe, a gesture. For phase 3, we take the output of the action segmentation and classification phase, and we generate the low-level script that is used in order to rerun the events on the actual device. This script is then pushed onto the device and is ran using the previous research tool called ReRAN. To evaluate our approach, we used 5 different research questions. However, I'm only going to cover 2 of them, which is the accuracy of the replays and the perception that we got from a developer survey that we generated. For the accuracy, we conducted 2 user studies. The first involved 8 users from our college, where we gave them 20 applications and had them record bug reports from real bugs, as well as bug reports where we inserted the bugs, as well as natural scenarios from popular applications. For the second study, we had 3 of the authors generate natural-looking scenarios for 64 applications in the different categories in the Google Play Store. We measured a variety of different metrics, such as the precision and recall of V2S. Overall, V2S had a precision and recall for classifying the action as 95% and 98% respectively. For the overall ability for V2S to properly reproduce the mobile app usage in the video, we found that overall V2S was able to successfully reproduce 96% of the bugs and crashes and 91% of the natural scenarios. For RQ5, we interviewed 3 mobile developers from Google, Proximus, and 7-Eleven, where we took their application that they worked on, generated our own scenario in that application, and ran the video through V2S. We then recorded this replay from V2S's reproduction and sent it to the developers and interviewed them. Here are some of the responses from the developers. So on usage data, V2S could collect the types of interactions, number of tabs, etc. For example, if certain screens are frequently used. On reproduction, V2S could be potentially useful for helping replicate hard to reproduce bugs. And overall, the perceived usefulness of V2S from the developers was high. In conclusion, I talked about the motivation of comprehending videos in an automated manner to reduce some of the stress that mobile developers face due to this influx of video data. Our approach, V2S, is where we attempt to help with some of these issues by reproducing the actions in videos. And I also discussed the evaluation of the V2S approach. We have open source V2S, so you can visit our repository, our website to get the code and data. Thank you very much for your time, and if you have any questions, please let me know. I'd be happy to answer any and all of them.